Rupam. I am first year undergrad student at IIT Roorkee. Today we will be discussing about Titanic case study template. Problem statement. The problem statement is to build multiple models on Titanic dataset and comparing the accuracy. Output, predicting whether the person will survive or not. Number of features are 10. Data volume, there are 668 rows and 10 features, so total 6680 data points. Data source is Kaggle, and the first 5 rows of the dataset are printed below. Here you could see that there are 10 features, and survived is our output which we need to find out. So the first step in every case study is data pre-processing. So first we'll do null filling, right? So we'll find the Titanic set is the name of the data set. So Titanic dot is null dot sum. So here we can see that age have 132 null values, cabin have 514, and embarked have 1. So we need to treat these null values. So firstly I'll do fill null values of age with the mean of age. So I filled it with the mean. Then dropping the cabin features, since more than 75% of the values are empty. So we know that 668 were the total rows and 514 are empty. So more than 75 are empty, so we'll drop it, right? And then filling the embarked null value with most occurring value. So we have done the value count and we could see that S is 484, it is 133 and 50. So S is more than twice the C. So therefore filling the one null value with S only. So here we have done that. The next is outlier treatment. So outlier is basically the accidental values in our data set. For example, if we saw any age equal to 150, so basically that is outlier, right? So since there are not much outliers detected in the data set, so we'll skip the outlier treatment here. The next is encoding, right? So encoding is basically our the model will not be able to, they do not process this type of text like the female or male, whether they processes the numbers like 0, 1, 2, etc. So what we need to do is, since we know that here we have seen that the sex column and the embarked column, they have the text value, so we'll convert them into the numbers by using encoding. So we'll import the pre-processing and we'll do the label encoder function, and then we'll fit transform these two things, the sex and embarked thing, right? Then moving on to feature engineering. So feature engineering is basically removing those features which are not playing any role, and also feature scaling, etc. So here I am dropping the name and the ticket number. Since the name, whatever is the name does not matter and whatever is the ticket number does not matter, so we'll drop both of them from our data set. And then here, now before starting with feature scaling, let us separate our features and output. So our features were those 10 features which I have shown you before. Now it would be 8 since we have dropped the 2 features. 3 features, we have also dropped the cabin over here, right? And then this the output, right? So output is denoted by Y, and we'll write survived is our output, and remaining except survived all belongs to X, right? Now is a time for feature scaling. So feature scaling, we do it so as our model converge quickly, right? So when we do the feature scaling, we import the standard scaler and we fit it and we transform it. After here, the scaled X comes out to be an array, right? So we use the pandas to convert it to data frame again, right? So scaled X is an array, we have used this to convert it to data frame again, right? Now our data is pre-processed and is ready for analysis. So we'll do EDA now. So first we'll plot various plots and we'll take some takeaways from it, that what these plots represent or present, right? The first is count number on the y-axis and survived on the x-axis. Here we could see that very less people have survived. 1 is for survived and 0 is for not survived. So very less people have survived and more people have died, right? Then moving on to sex, how sex of a person defines whether the person will survive or not, right? So here 0 is for female, 1 is for male, and we have plotted it over here. So this shows like the number of male and females over there. This is number of females are around 250 and males are around 400. Here we have plotted the survived with the sex, right? So this is for females. So most of the female have survived. Here we could see that only 50 have died and 200 have survived. And in case of male, most of them have died. 350 males have died and only 100 have survived. So we could take away from that around 75% of the women have survived, whereas only 20% of the men have survived, right? So it shows that sex is playing a role in our data set, right? Then moving on to the next feature, that is P class, that means passenger class. So here we have plotted, and here we could see that the most chances of survival are in passenger class 1. See, it is more than this, it is 50, it is 100, so almost 66% survival. Here you could see that it is almost 50%, and here it could see it is around 20% or something in the passenger class 3. So takeaway is passenger class 1 have most survival chances, whereas passenger class 3 have least survival chances, right? Moving on to next feature, that is embarked. So there are 3 categories of embark, and we have named them 0, 1 and 2 after we have encoded them. So we could see that this embarked 0 have most chances, embarked 1 have okay chances, and embarked 2 have least chances, right? So here we takeaway is embarked 0 have most survival chances, whereas embarked 2 have least survival chances, right? The next thing is fare. So we will first notice that how much people have paid in this. So we have seen the count versus fare plot, and we could see that most of the people have paid less than 100, right, while traveling with the Titanic. And when we'll group it with the survived part, you can see that this blue is for fare and this orange is for people who have survived, right? So it looks that who have paid more have more chances of surviving. So you could see that those people who have paid more have almost survived, right? All have survived, but here few have died, right, who have paid less, right? Then comes the part of age. So this shows that most people are in the middle age, right? And then when you group it with survived, you could see that the very younger people have survived and normal people have somewhat died and somewhat not died, right? So this could be one takeaway, that very younger people have almost survived, right? Then now is a plot which contains both age and fare along with survived, right? So here you could see it looks like those who survived either paid quite a bit for the ticket or they were young. Like you could see that this is the age column and this is the fare column, right? Those who were young or those who have paid more have survived. You could see those who are old and have paid less have died almost. They have almost died, right? So that is a takeaway, that young people or those who have paid more, you could see that those who have paid more have more oranges, right? So this may be the takeaway from here as well. Then is error matrix. So error matrix is something which we choose to compare the performance, right? So here we could see the available options are confusion matrix, F1 score, AUC, ROC, RMSC, MSC, accuracy score, log loss, etc. So here I'll choose the accuracy score to compare the performance of the model, as our model focuses on true results. So we already know the definition of accuracy, that is true positive plus true negative divided by total samples, that is true positive, true negative, false positive and false negatives, right? So I'm choosing the accuracy score for comparing the performance, right? So coming on to our first model, that is a regression model. So here the assumptions taken are the observations are independent of each other, right? The observations are independent of each other and hyperparameters selected are default. So first have a look over here. From sklearn.linear model, import this model, then create a logistical regression classifier equal to, like, logreg is the name of my model, equal to logistical regression, and then you need to train the model by using .fit and xtrain, ytrain. Before you need to let me tell you that I have split my dataset into xtrain and ytrain and xtest and ytest. So the training part I'll use to train my model, and to test it I will use the xtest and ytest part, right? So what I'll do is I've fit the model, I'll predict it, I will use the variable ypred1 and I'll predict on xtest, and then I'll compare the accuracy of comparing ytest and ypred, right? So this is the accuracy of our model, that is 80.24. Hyperparameters are something which we put inside this, right? So since we have put nothing, so they will take the hyperparameters as default, and accuracy report is 8.24 as you could see from here, right? The second thing is decision tree. So decision tree is something which works on, like, here is a node and it then divides into 2 or 3 leaf nodes, right? So the features must be categorical to get divided into the further leaf nodes, right? So let us come over to the code. So it shows that we have first imported grid search CV. So what is grid search CV? To tune our hyperparameters we use this. So firstly let me make a model, DTC equal to, DTC stand for decision tree classifier only, and put it equal to this. So here I'm tuning my hyperparameters, I'm making a dictionary parameters equal to all these things, and then I'm running the grid search where I'm passing this model and these parameters, this grid search, and then I'm fitting it, and then I'm finding the best estimator. Best estimator means the best combination of the parameters will be found out, right? And then we'll fit our model, and here when we'll fit our model, in the bracket there comes the hyperparameters with their taken values, right? And then we'll predict it, and similarly we'll find out the accuracy, right? And here you could see the hyperparameters selected are these one, and you could also see it from here as well, and accuracy report is 80.24 as you can also see from here, right? Next model, that is random forest. So here we'll again import the grid search and then the random forest classifier. We'll create a model, we'll put some random values to these parameters, and we'll run the grid search, and we'll pass the model, we'll pass the parameters, we'll fit it, and then we find out the best combination, and then we'll again fit the model to it, and again it will appear this hyperparameters over here, and then we can predict, and then we can find out the accuracy, right? So you could see that it is quite similar to decision tree. The hyperparameters are written here, and assumptions are the observations must be independent of each other over here, and this is the accuracy report, right? Moving on to next model, that is boosting, and I've shown gradient boosting algorithm over here. So this is also self-explanatory. all these steps are quite similar. Its sum of residual is 0, that is the assumption which is different, and other things are almost quite similar, and you could see that accuracy is highest among all till now which we have observed, 84.43. right. Moving on to our next model, that is a deep learning model which is neural networks. So here we do not have any need to assume any underlying pattern of data, and here we will import the MLP classifier and will put the hyperparameters to it and will fit it, and then we'll predict it and find out the accuracy. This is one way to do this kind of stuff, the neural network part. There is one other way which I'll show you. Here you could see this is the another way for neural network. Here you could put the model equal to sequential function, and then you could add the layers by using add and dense feature, and here you must write the units of the neurons of this layer, and you could skip this kernel initial for now, and then we put the activation function and initial input layers, that is the input features which we are giving. For example, in our case it is 7 features were left, and then in the we'll add more layers and we'll add one at the end, and here we'll use the activation function as sigmoid is the best activation function for binary classification. And then we'll combine our model where we'll use optimizer as Adam. 90 to 95% of the time we use this optimizer. Then we'll use the loss equal to binary cross entropy. It is used when we want to, when our output is between 0 and 1, and matrices is accuracy in our case. We'll fit it, and here we have given the batch size and epochs. So batch size is basically if we have large rows in our data set, so we provide a batch size that take this at a time. So it will process 32 rows at a time, and epochs is number of times, so it will process 32 rows at a time and 100 times all the batch sizes, all the batches 100 times, right? So in every epochs the accuracy will keep increasing. The only thing to take care in while setting the epochs is that your model does not overfit, because if you will do more and more epochs, right, so the model will learn those things and it will overfit, right? So it will, although accuracy will be good on your training dataset, but it will significantly fall on your testing dataset, right? So this was all. The next thing is performance comparison, that is the table results from all the models. So these were all our 5 models and these are the accuracy. So we could see that boosting gives us the best result while in binary classification, right? So thank you so much for watching.